Section 2.6 Example 2 on page 136, we have another way to decide if a relation is a function is to analyze the graph of the relation using the vertical line test. If any vertical line passes through more than one point on the graph, then for some domain value, there is more than one range value. So the relation is not a function. So example 2 says, is the relation a function? Use the vertical line test. Notice that part A gives us the points right away, so we're just going to plot these points and then use this vertical line over here to check whether or not it passes. For part B, we have just the equation, y equals negative x squared plus 3. So to check this, we're going to make a table of values to get some coordinate points that we can plot, and then we'll use our vertical line to test it. For part A, we have negative 4, 2, so we're going to go to the left 4, up 2. Negative 3, 1 is to the left 3, up 1. 0, negative 2 means we go down 2. Negative 4, negative 1, go to the left 4, down 1. And 1, 2, you go to the right 1, up 2. Now, we're going to use this vertical line right here. When you are doing this on your own on a piece of paper, you can use your finger, you can use a pencil, anything that makes a perfectly straight line. So a pinky works pretty well because you can run it across your paper. It doesn't matter which side you start on. So all you're going to do is move your vertical line across your graph, and every time you hit a point, as long as that's the only point you hit, you're good. So notice this orange point is only getting hit by itself. The purple point is getting hit by itself. The blue point's getting hit by itself, but my green and my pink points get hit at the same time. That's not good. That means this did not pass my vertical line test. Therefore, part A is not a function. If you want to be very specific about why this is not a function, we would say the input negative 4, notice we had two negative 4s, had two outputs, 2 and negative 1. For part B, I have written the equation y equals negative x squared plus 3 and chosen the points negative 2 through 2. So all we're going to do is plug in these values, get out a y value, and then plot whatever points we get. When we plug in negative 2, we get negative 2 times negative 2 is 4. So negative 4 gives us negative 4 plus 3, which is negative 1. So we get the point negative 2, negative 1. When we plug in negative 1, we square that, we get 1, but we have the negative, so we get 3 minus 1 is 2. We get the point negative 1, 2. When you plug in 0, of course, anything times 0 is 0, so we end up with just 0 plus 3, and that gives us the point 0, 3. When we plug in 1, 1 squared is also 1, so we get negative 1 plus 3 is 2, so we get the point 1, 2. And when we plug in 2, 2 times 2 is 4. Keep your negative. Negative 4 plus 3 is negative 1. So you get the point 2, negative 1. Now we're going to plot these 5 points. After we plot the 5 points, we can go ahead and draw a curve or a parabola through them, since this is a quadratic equation. Now we're going to take our vertical line and go across the graph to check if it passes. Again, it doesn't matter which side you start on, just check every time you hit a point. We've hit the green point, it's by itself, the blue point is by itself, the purple point is by itself, the pink point is by itself, and the orange point is by itself. And all the points on this curve, in fact, get hit once at a time. So of course our red line's a little thick, so it might seem like we're hitting more than one point at a time. But if you used the thinnest vertical line you could have, you would be hitting 1 point at a time. So this indeed passes the vertical line test. So we say that part B is a function. This next slide has part A on it, and then we have part B with some extra explanations. And for the next U-try, number 3 on page 136, it says use the vertical line test to determine whether the relation is a function. You can use your pinky, you can use a pencil in your book, and just go across the graph and see if you hit more than 1 point at a time.